Bismillah, Alhamdulillah, wassalatu wassalam ala Rasulillah, amma ba'd. Welcome to today's talk, Islam, Evolution and Darwinism. Now the first thing I want to cover is this image. Now with Coca-Cola, you get the red color and the white color and that, that stylistic sort of writing. Instantly you recognize that's Coke, that's, what they're about and, their branding, whatever. If there is an image in the world which represents Darwin's theory of evolution, it would probably be this image, this marching band towards progress. And the reason why I want to cover this right at the beginning is because the main objective of this talk is to show that there is a huge difference between the way that Darwinian evolution is pursued and the way it's actually perceived by members of the public. And this is the most iconic image that relates to Darwinism. Yet, if you read the works of secular mainstream academics about this particular image, they will say this is this is a misrepresentation of actually what Darwinian evolution is about. They would say this image is actually false. And the reason why they would say it's false is because Darwin's theory of evolution, it doesn't head towards progress. There's none of this inherent thing about you need to get bigger, more complex, more intelligent. It's all about survival and reproduction. So Henry Gee, he is an evolutionary biologist. He's the senior editor of Nature. In his book, The Accidental Species, he has this image and then he says, this is totally false. We as human beings, we're not at the apex of a long evolutionary process and we are somehow at the top. He says this goes back to an old idea known as the Great Chain of Being, and it's like a quasi-religious idea, and he says it's false. He says this is false, and likewise you'll find Professor Michael Roos in his book published with Cambridge University, The Philosophy of Human Evolution. Again, he takes this image and he says, this is not the way that evolution works from a Darwinian perspective. And the reason why I want to cover this at the beginning is because this will help you understand just how much misconception there is about the way that Darwinian evolution is actually pursued and the way it's actually perceived. And today is really going to be about paradigm shifts. So here's the 5 things I'm going to cover. Science and certainty. Does science lead to certainty? Does its conclusions, are they written in stone? Are they something which are not going to change? Secondly, the current state of Darwinian evolution. The fact that it is based on a probabilistic framework. It has multiple assumptions which are being challenged by other evolutionary biologists, and there are disputes and alternatives to it. Also, I'm going to be covering the existence of God and Darwinian evolution. What's the link? What's the link between atheism, evolution, from a Darwinian perspective? Why is Darwinian evolution unique? Because it is the only scientific theory in history which has, according to mainstream secular academics, morphed from a scientific theory into a religious system, into a political system, and also into an ethical system. How did that actually happen? And lastly, I'm going to be covering the connection between Islam and evolution, and Islam and Darwinism. Now, just to give you the main upshot right at the beginning, what is the Islamic stance on the Darwin's theory of evolution? Well, we can answer that question in a very simple way by saying, what is Islam's stance on any scientific theory, not just Darwin's theory of evolution? And the stance that we as Muslims have is the same stance which even secular academics have, which is that science leads to working models, working theories, working paradigms. It doesn't give you certainty. So we can, as Muslims, we can accept it as a prevailing theory, as a prevailing paradigm, as a prevailing model in science, but we don't have to say it's absolutely true or take it into our creed. Okay. All of the people I'm going to be referring to today are going to be mainstream secular academics. They're not going to be people linked to intelligent design, creationism, anything like that. And they're all going to be mainstream secular academics. The first thing we need to do is speak about what is science, because there's a lot of misconception about what science actually is. Now, if I was to speak about what is science, we could be here till the cows come home. It's a very deep subject. But in a very simplistic view, is that science is using observations to come up with hypotheses and testing those hypotheses against observations. And over time, as you repeatedly test hypotheses, you come to a theory. And the highest level of certainty you can reach in science is a theory. Now, sometimes in our common language, when we speak about theory, we say, my theory is, we didn't go to the moon, or my theory is this, or my theory about, who shot, Kennedy. We use it in that sense. But in the scientific literature, theory is something very substantial. It's not just a hodgepodge idea. I just have this idea, I think this is my idea and this is my theory. In science, you have a hypothesis which is tested, which is generally accepted, and then it's elevated to a level of a theory. Why is science amazing? Because it actually works. And this is something which we benefit from all the time. Now, if you imagine you have Isaac Newton's equations, right? These worked well for 200 years and they were fantastically precise. And we actually went to the moon based upon Newtonian equations, the Newtonian laws. What's really interesting is even though science works, it doesn't mean it's absolutely true. And as we're going to be covering, there's two main reasons why science doesn't lead to certainty. The first is what's known as the problem of induction. I'm just going to give you a simpler way of trying to remember it, is the black swan problem. Say there is a scientist who wants to find out what color are swans. So he repeatedly tests the idea, what color are swans? And he comes up with the conclusion all swans are white because all the swans that he's come across are white. So you take a limited set of observations and you go to a general conclusion. But in the future, you can always come across a black swan, a novel piece of data, which will challenge your previous conclusion. So this is the black swan problem, or the problem of induction. Secondly, there's the issue that the same observations can give rise to multiple alternative theories. Imagine a scatter graph. So you have this scatter graph and you have all this data plotted at different points. Now, if I was to ask you, every single person in this room, if I was to give them the scatter graph and say, draw what you consider to be the best representation of this data. The brother here might draw a straight line. The brother at the back, he might draw, a sine curve. The sister in the middle, she might draw a bell curve. Everyone can make many different alternative lines based upon the same observations. And remember, those dots are observations. So alternative theories are possible on the same observations. This is the scatter graph problem. And together with the black swan problem, these two things lead us and lead philosophers of science to unanimously agree that science does not lead to certainty. Science doesn't lead to absolutes. It leads to working models which are then falsified. Science doesn't prove, science can only disprove. Now, what doesn't obviously change is direct observation. So we have the existence of gravity. We have the observation that water is composed of hydrogen and oxygen. We have the observation that that is a trilobite. We have the observation that DNA is a genetic code. These observations do not change. So these are certain. And sometimes there's a confusion between an observation and a scientific theory. We say, no, science does lead to certainty because we know the shape of the earth, or science does lead to certainty because we've discovered DNA. Well, observations can lead to science and observations can lead to what's known as pseudoscience. So you can use observations of, stars, and you can come up with theories related to, their motions. You have astronomy. You can also observe the stars and come up with a pseudoscience such as astrology. Science is way more than observations. So be careful when, somebody tries to say, science does lead to certainty because, look at the length of the tail of the crocodile. That's not going to change, is it? But that's an observation. We're talking about scientific theories. Scientific theories are not certain. Scientific observations, of course, they're not going to change. They're always going to be around. And the history of science from physics, chemistry, biology shows that science goes through these paradigm shifts. Thomas Kuhn, he is a very important philosopher of science. he published a landmark book known as The Structure of Scientific Revolutions, and he showed that science goes through these paradigm shifts. Now, what are paradigm shifts? You know, we get those two images which are two faces which are looking at each other. You have that image, you look at it from another perspective, and it's like a vase, right? So, you know, it's a complete, what's known as in psychology, a gestalt shift. It's a complete shift in a worldview. And this is exactly what has been happening in science over a long period of time. One of the examples, which is a classical example of a paradigm shift in science, is Newtonian to Einsteinian physics. Newton's theory, Newton's model of the universe worked well for 200 years. It made precise predictions which were confirmed and reconfirmed and reconfirmed. And if you were to make a prediction using Newton's model of the universe and saying, where is this planet going to be on this particular time of day, and you were to go out and observe it, you would find that it would be there. Yet Einstein came along, and black swan problem, scatter graph problem, he created a paradigm shift within physics. He said, yes, Newton may have worked well for 200 years, but gravity is no longer, according to him, a pulling force. It is a pushing force due to space-time curvature, which is the exact opposite of Newtonian physics. Even the definition of mass changed. Now imagine a scientist who's calculated, you know, all these calculations, and he's reconfirmed them, and, you know, somebody walks into his room and says, by the way, your definition of mass is actually defined incorrectly. Einstein showed that it was, you know, it was this. He'd be shocked because it'd been working for so well. Likewise, time and space, according to Newton, were assumed to be fixed, rigid. Einstein came along and showed, actually, no, they're dynamic. You have space-time curvature, which changes. So these concepts, which were so fundamental, which were taken for granted, which people believed to be true, like literally true, were then shown to be not true. And that's what actually happens in science. So this is a classical example of a paradigm shift in science. Now, theories work even when they're wrong. A classical example, apart from Newtonian mechanics, is the theory of phlogiston. Phlogiston was a theory in chemistry which was used to discover nitrogen, yet later it was discarded. Theories work even when they contradict each other. So currently, in the world of physics, we have a very successful theory, general relativity as proposed by Einstein, and we also have quantum mechanics, which again is very successful. But the fundamental assumptions of these two contradict each other. They both can't be true. Yet, scientists don't say, well, I'm going to choose this over that. They say, well, let's ride both these horses, right? So we have, even today, in physics, an unresolved conflict between two theories which are really powerful, which both have so much predictive scope, yet, but they both can't actually be true. And they're trying to come up with a theory of quantum gravity or something like that, but they haven't managed to do that yet. Science changes even if it works, and historically you will find, if you pick up any book on the philosophy of science, you will find something like this. This is what it says in a very short introduction by Oxford University about the philosophy of science. Historically, there are many cases of theories that we now believe to be false, but that were empirically quite successful. And again, this is a publication by Cambridge University, Evidence in Evolution, the logic behind the science. The best a scientist can do at any time is render comparative judgments. So imagine the scatter graph. Somebody has a bell curve, somebody has a sine curve, and the best scientist can do is choose one over the other. That's the highest level of certainty science can reach. And again, another standard philosophy book from Oxford University, Science is Revisable, hence to talk of scientific proof is dangerous because it gives you the idea that conclusions are written in stone. So this is not something which is controversial. Even the most well-known Darwinist in the world today, Professor Richard Dawkins of Oxford University, even he admits in his book, A Devil's Chaplain, that new facts may come to light in the future which will force our successors of the 21st century to abandon Darwinism or modify it beyond recognition. Now, Darwin's theory of evolution, you know, it's got a lot of, I would say, misconceptions around it. It's got a lot of sometimes proponents which step over the evidence, they speak way beyond it. Now imagine if you're sitting here and you know, I'm here to give you a lecture about Darwin's theory of evolution, I'm a Darwinist, and I say to you, look guys, Whether you look at biochemistry, whether you look at genetics, whether you look at anatomy, whether you look at psychology, whether you look at sociology, whether you look at morphology, whether you look at language, whether you look at biogeography or the fossil record or paleoanthropology, every single subfield in biology leads you to one conclusion, which is Darwin's theory of evolution is true. Well, that is the sort of perception that some Darwinists try and promote. And they promote it through popular books. They try to promote it through social media as well. But there's at least three things we can say about Darwin's theory of evolution which are unanimously agreed upon, which no evolutionary biologist would challenge, which is that Darwin's theory of evolution is based on a probabilistic framework. It has multiple assumptions which are being challenged by other evolutionary biologists, and there are alternatives and disputes, and there's a lot of dissension about its most fundamental ideas. And this is all within the framework of mainstream secular academia. So probabilistic framework, assumptions, and disputes. And I'm going to be going over each one of those now. First thing we need to do is we need to make a distinction between evolution and Darwinian evolution. Evolution as a general idea of biological change over time has been known and written and documented and thought about and theorized about for at least 3,000 to 4,000 years of human history. We have documents going back to the ancient Chinese, to the ancient Brahmins in India, to the ancient Greeks, speaking about biological change over time. But there's a difference between generally believing in biological change over time, which is generally an observation. There is biological change over time. And Darwin's idea about evolution, his theory of evolution. Now, in 1809, Jean-Baptiste Lamarck, 50 years before the publication of The Origin of Species, a French biologist, he published a comprehensive theory of evolution, which had a history of evolution and a mechanism of evolution. The history of evolution was the hedge of life, which was multiple, endless origins of life with parallel lines of evolution taking place, and also a mechanism which was the inheritance of acquired characteristics. 50 years after him, Darwin, in 1859, he published again a theory of evolution, which was different to Lamarck, which was, in terms of its history, a total paradigm shift. Instead of multiple lines of parallel evolution, he said, no, there's one origin, and you have a tree of life, and the driving force is natural selection. So there's a difference between evolution and Darwinism. The reason why I'm highlighting this is because when there's some well-known Darwinists who say, well, this is Darwinian evolution is absolutely true, and when you ask them evidence for why it's absolutely true, they don't give you evidence that the tree of life is true. They don't give you evidence of natural selection being the driving force behind the tree of life. They just say to you, look at butterflies, they change. Look at bacteria, they change. Look at human beings. Our skin colors are a product of our geographical distribution. This is all evolution. Yeah, but no one disagrees. Even the most, the most primitive human being who's had no interaction with, the civilized world, who lives in the Amazon, even he would agree that there's biological change over time, that evolution is an observation. We're not speaking about that. Darwinian evolution is a history, which is the tree of life, and a driving force, which is natural selection. That is something which is a theoretical framework, and that is not absolutely true. Unlike evolution, which is just an observation, it's true. Now, according to mainstream secular academics, it's very difficult to try and calculate what happened on this planet for the last 4 billion years, approximately. And one of the analogies, which is given in a peer-reviewed journal known as Science, is it's like trying to work out the plot of Leo Tolstoy's War and Peace with 13 randomly selected pages. Now imagine you have that book. It's a huge book. It's about 500,000 words. And you have 13 randomly selected pages. And to each person in this room, I just give you a copy. And then I say to you, you have 13 pages. All the rest of the pages are blank. Now fill out the rest. What happened? How does it begin? How does it end? Which characters go? Which characters go? Which characters come in? You'll all give me different stories. Well, it's the same problem with the fossil record. It's the same problem with the history of life on Earth. It is incredibly difficult to try and come up with a scenario when we're speaking about something that happened 4 billion years ago. Secondly, according to the National Science Foundation in a study published in May 2016 last year, 99.999% of species are unobserved. Okay? That basically means all we have in terms of our data, in terms of our fossils, in terms of our the animals which are alive today, the biological life which is alive today, all we have is 0.0001%. What does that mean? That basically means it's Leo Tolstoy's War and Peace, but on steroids. Or, like I've put it here, it's the scatter graph on steroids. It's so incredibly difficult. This is the reason why evolutionary biologists have looked at the history of life on Earth, and they've come up with multiple alternative, contradictory ideas. Some have looked at it and they said, perhaps, like Darwin said, all of life going back had one single origin, and that one single origin, you have the tree of life, universal common ancestry. Others, like those who believe in neo-Lamarckian evolution, they said, and like Lamarck proposed, there was multiple lines of evolution, multiple origins, there was this hedge of life. Others today are saying the tree of life is incorrect, like Carl Woese, and they say, he's the one who discovered the third domain of life, archaea, very important evolutionary biologist. And he says, it's a web. It's not a tree of life, it's a web. And that a web is, this idea has been coming around just for the last 20 years. Before that, the tree of life was generally accepted by everyone. Some say it's gradual. There's very small incremental gradual change, which is classical Darwinism. Others say, no, there's rapid change. Some say there's progression, like Lamarck, and some say there's no progression, like classical Darwinism. Whatever you make is bound to be speculative. It's bound to be based on a probabilistic framework. Also, what's very, very important is how, if I was to ask you that there's amazing traits that human beings have and there's amazing traits that exist in nature, how did these traits come? Usually when you watch a documentary or when you read a book, it gives you a scenario. But how do you know if that scenario is true? And many times we've been given, okay, how did the eye come around? How did this come around? How did that come around? Well, maybe what happened was this, maybe what happened was that. These scenarios, they sound quite plausible, but the problem with them is we don't know if they're actually true. Now, Richard Lewontin, a very important evolutionary biologist at Harvard, again, mainstream secular academic, he's an atheist, alongside people like Stephen Jay Gould, again from Harvard, both evolutionary biologists, they popularized this term, just so stories. Just so stories goes back to Rudyard Kipling's book, Just So Stories, in which, it's how did the elephant get its long snout? Well, the crocodile bit it and it tried to drag it into the water, and as it kept dragging it, it got longer and longer and longer and longer. Now, that is a just so story. Why is Richard Lewontin and Stephen Jay Gould and others calling these evolutionary scenarios just so stories? Simply because you can't really test them. So if I was to just speak about one trait, and in terms of human beings, in terms of our biochemistry, our genetics, our anatomy, we have so many different traits. But if I was to just give you one trait, we have blood vessels that run throughout our body, and the blood vessels are obviously sealed. They're not, they're not leaking into the rest of your body, except in one part of your body, there's actually a leakage. Right? Sounds scary, but there is actually a leakage. You actually have the blood-brain barrier, and you have a vessel which goes through, a vein that goes through, and you have a slight leakage. And what happens is the blood that comes out, it's actually tested by the brain, and the brain tests if your body actually has toxins. And if your body has actually had toxins, and you've had a late night kebab in Oxford from a very well-known kebab shop, which I'm not going to mention, which is near a cinema, opposite a cinema, okay? I used to go there many, many years ago. Say if there's something dodgy in the food, which, we know it's not going to be, it's a great place. Say if that happens, your body will discover it because of this leakage. And then it will create a reaction to mitigate the effects of that. Now, how did this trait evolve? If you were to go up to a Darwinist, they would say, perhaps what happened is this, perhaps what happened is that. This is what's known as just so stories. I'm just going to cover one just so story, which is the color preference. Okay, so to actually help me, and this has actually helped me today, there's a brother wearing a jacket which is blue, and there's a sister who's wearing a red scarf. Now, why that is helpful is because evolutionary biologists, Darwinists, they have to explain every single human trait, whether it's biochemistry, genetics, anatomy, psychology, sociology. They have to explain it in terms of natural selection. So how did they explain color preference? Because men like the color like the color blue, and women like the color red. Now, what some evolutionary biologists, some evolutionary theorists did is they came up with the scenario that approximately 1 million years ago, when human beings lived in hunter-gatherer societies, men had to go out and hunt, and if they had to go out and hunt, they had to look out for a blue sky. So they started liking the color blue. I mean, the ones who like the color blue are more likely to survive because they're going to go out and hunt. And when they go out to the watering hole, it's also blue. Also, that gene for liking the color blue, that mutation, will get passed on because the people who go out and hunt are more likely to survive. Now, the women who, they were at home, so the men would obviously go kill a mammoth or something and bring it back, and you have a lot of color red. So the women who interacted with the color red started to they were more likely to survive if they preferred the color red, because they're going to be noticing that. Also, when women go out, they forage, right? According to that scenario 1 million years ago. So when the men are hunting, the women are going out and picking berries, picking strawberries, picking apples, which are red. So that's how they came up with the idea that men like the color blue and women like the color red. Now, Raymond Tallis, he's a scientist and an atheist and an evolutionary thinker and a philosopher. He's a polymath, amazing guy. What he does is he challenges that particular scenario, and he says, guys, come on, this doesn't make any sense. Women liking the color red and men liking the color blue is a very recent phenomenon. 150 years ago, just here in Victorian Europe, men liked the color red and women liked the color blue. Just 150 years ago is actually the other way around. Hence, Alice in Wonderland, she's got a blue dress, knights and, those sort of people, they used to wear pink or red, they used to like those sort of colors. So he says, look, this just so scenario doesn't make any sense. The reason why I'm highlighting this is because there's a clear difference between what's theoretically possible, a theoretical story or theoretical construct, which is what we hear all the time in very popular documentaries. How did a human being evolve to walk upright? Well, what could have happened is this, what could have happened is that. These are just so stories and you can't actually test them. There's a difference between what is theoretically possible and what actually happened. Okay, another thing, Darwin's idea of the tree of life is based on a fundamental assumption. And that fundamental assumption is that of homology. Homology is the assumption that if there is similarity, then this similarity is due to common descent. This is how they look at a human being and a chimpanzee and they say, look, there's similarities, therefore there is a common ancestor. Now, first thing to know, this is an assumption, okay? So even if there was no other evidence against it, it is an assumption. And if someone says it's plausible, well, that's fine. But you can't say it's absolutely true. It's just an assumption. No one saw human-chimp ancestry split 6 to 7 million years ago. And just a few years before that, they said the human-chimp ancestry didn't split 6 to 7 million years ago. It was 20 million years ago, which was a 14 million year revision. So no one was around at that time to see this split. But nonetheless, homology, which is used to construct the tree of life, you take similar things and you put them together, they have a common ancestor. This assumption of homology has a counterfactual, which is known as homoplasy, which is the exact opposite of homology, which is similarities which cannot possibly be due to common descent. And all over the biological world, at a biochemical level, at a genetic level, at an anatomical level, we have these homoplasies. Here's some classical examples. We have the wing of a bat and the wing of a bird. That is not due to common descent. That is homoplasy. Likewise, and that's in terms of physical features, if you go to genetics, the bat and the dolphin, they both have genes for echolocation and they both have the system of echolocation. So if you look at their genes, they're the same, yet it's not due to common ancestry, it's due to homoplasy, not homology. And recently there was a paper published by Andrew Inkpen and Ford Doolittle called Molecular Phylogenetics and the Perennial Problem of Homology. And they basically said, we have this huge problem. We look at similar things and we say we have a common ancestor, but then we have so many similar things genetically which cannot possibly be due to common ancestry. Another classical example is the placental saber-toothed tiger and the marsupial saber-toothed tiger. I mean, you guys can Google this, it's fascinating stuff. When you Google and you look at both of them, they look, if you just have a superficial look at them, they just look so, it looks like it's the same thing. It looks like they are both the exact same thing. Yet, one is from North America, one is from South America. And the marsupial saber-toothed tiger and the placental saber-toothed tiger, they didn't interact. They didn't breed. They are two separate species which had separate origins. In fact, if you look at both of them, the placental and saber-toothed tiger look very similar, yet the placental saber-toothed tiger is closer to a kangaroo than it is to a marsupial saber-toothed tiger. So we have this huge problem of homology. It's a quagmire, and quagmire is not the guy from Family Guy. It's quicksand. It's a big problem to actually deal with. Okay, some examples a bit more particular to human beings when it comes to homology, homoplasy. Now, a lot of the times we get this very simple narrative. Look at the human being, look at this particular part of the skull, or look at this particular elbow. It's so similar to that of a chimpanzee, therefore there must be a common ancestor. Again, it's an assumption. And we know counterfactuals to that assumption, such as homoplasy. Now, in terms of human being, we have an amazing language. We have this complex specified language. The only creature in nature which is closest to the human being in terms of our language is not the chimpanzee, because chimpanzees grunt, is the songbirds, is actually songbirds. They have the closest to human beings in terms of language. That's not due to homology, that's homoplasy. Secondly, chimpanzees live in communities up to 100, no longer than 100, no bigger than 100. Yet, the closest to the human being in terms of our social behavior is actually the ant. Ants live in colonies of millions. All of the ants are genealogically related. All of them are brothers and sisters. Ants have, and this is fascinating, chimpanzees live up to a community of 100 and they don't have a complex social structure. Ants have complex buildings. They have economies. They have warfare. They have slavery. They even have funerals. It's the closest to the human being in terms of our social interactions. That's not homology, that's homoplasy. Yet, this sort of information is often overlooked. Now, just to summarize this point about homology and homoplasy, sometimes we get this very simplistic narrative. Look, that's similar, therefore there's a common ancestor. There must be. Even according to mainstream secular academics who don't believe in God, this is not true. It is actually based on it's not true in an absolute sense. It's based on a probabilistic framework. This is what it says in Evidence and Evolution published by Cambridge University. Both of the following thoughts are therefore naive. Humans and chimps must share a common ancestor because they're so similar. And humans and mushrooms must have arisen independently because they are so different. Within a probabilistic framework, there is no must in either case. Finished off the probabilistic framework section, now we're into the assumption sections. There's a whole bunch of assumptions that Darwinian evolution is based upon, which is fine because all scientific theories have assumptions. The reason I'm putting this here is because these assumptions are actually being challenged. So we have natural selection as the main driving force of evolution. That's being challenged. Genes are transmitted vertically. We now know of the process of horizontal gene transfer. Gene-centered view, the selfish gene view, is being challenged by things like group selection. Gradualism is challenged by saltational processes. Tree of life, something which I never thought in my life I would see mainstream evolutionary biologists challenging. They're challenging it with the web of life now. Acquired characteristics are not inherited. You know, Richard Dawkins' book, The Selfish Gene, 1980s edition, he makes it clear it is impossible for acquired characteristics, things that you do in your life now, they won't impact your children. But actually, we've discovered processes that show that that is not the case. and mutations are random. Well, according to other evolutionary biologists, some mutations may be random, but most of the beneficial mutations are actually directed. They're not random mutations. According to just here, Professor Dennis Noble at Oxford, all of the central assumptions of neo-Darwinism have been disproven. Now, I'm not saying I agree with Dennis Noble here, but he's a mainstream evolutionary biologist at Oxford. He is a professor there and he's been there for a long time. He doesn't believe in God or anything like that, not to the best of my knowledge. And he just says, look, it's not true. This is not true. These assumptions, and he believes in alternative models, which we're going to be covering. Secondly, there's at least 5 fully fledged alternatives to Darwinian evolution. And this is very important because, people normally, Darwinism and evolution are synonymous. No, they're not. There's at least 5 well-known, well-established, complete alternatives to Darwinian evolution, which are proposed by mainstream evolutionary biologists who are atheists, who don't believe in Darwin's theory of evolution. They are evolution by natural genetic engineering, proposed by James Shapiro at Chicago University, neo-Lamarckian evolution, which is a rehashed version of Lamarck's evolution, which is over 210 years old now, mutation-driven evolution, which is also known as Mendelian mutationism, evolution by self-organization, this was proposed by Stuart Kauffman, and symbiotic evolution, which is the inheritance of acquired genomes, the inheritance of acquired genomes proposed by Lynn Margulis. I don't have time to go through all those 5 alternatives, but you will find books on every single one of these. And these are fully fledged alternatives to Darwin's theory of evolution. We have this project known as the Third Way of Evolution. The Third Way is called the Third Way because all of the people on this project, and we have people on this project from Oxford University, Cambridge University, MIT, Princeton, Harvard, Europe, America, China, evolutionary biologists all across the world. They call it the Third Way because these biologists don't believe in, creationism, intelligent design, God, anything like that. So they brush that aside. They can't accept Darwinian evolution because they're like, it doesn't make any sense. Its assumptions are falling apart. We've got this issue. So they say there has to be a third way of evolution. It can't be creationism, intelligent design. It can't be Darwinian evolution either. Now, I'm not saying I agree with the stuff that's on here. And to be honest, if you go to their research papers and their books, you'll spend years going through all the stuff that's published there. The only reason I'm highlighting this is to show there's a discussion going on. It is based on a probabilistic framework. There are assumptions and there are disputes and alternatives which actually exist. And one of the most amazing things which I found is Carl Woese, who discovered the third domain of life, archaea, he actually, not only did he challenge the tree of life or the web of life, he also believed in evolution by natural genetic engineering, which is a alternative to Darwinian evolution. Now we're going to move, we've finished probabilistic framework, assumptions, disputes. Now we're going to move into the area of God and Darwinism. Now what's very, very important to know is this. Axiomatically, if there is no God, if naturalism is true, then something like Darwinian evolution has to be true as a matter of logic. Now, I want you guys to digest that. It's quite a mouthful. If there's no God, if naturalism is all that there is, if nature is all that there is, something like proto-Darwinism, something like the Darwinian history of life has to be true as a matter of logic. Because there is no God, human beings and all of nature has to have some sort of tree of life-like picture. This is something which even the ancient Hindus 3,000 years ago came to. The Padma Purana is an ancient Hindu text about 3,000 years old. In this text, it mentions something amazing, which is the tree of life. It mentions human-chimp ancestry, that human beings and chimpanzees, human beings and apes, they have a common ancestor. Why did they come up with this? Because they believed in naturalism, they believed in natural processes. So they used, homology, which I previously described, and they had human-chimp ancestry. Now what's very, very important is axiomatically in biology, something like the Darwinian history of life has to be true as a matter of logic. This is what Gareth Nelson, a professor, evolutionary biologist, says. And he believes in Darwinism, by the way. He says, we've got to have some ancestors, meaning what? Human beings have to have non-human ancestors. We'll pick those. Why? Because we know they have to be there and these are the best candidates. How do they know these are the best candidates? Based on, again, homology. And again, the biologist Richard Lewontin, he basically makes the same point. And just look at this statement. It's absolutely telling. We are forced by our a priori adherence to material causes to create an apparatus of investigation and set of concepts that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, that materialism, which is naturalism, is an absolute, for we cannot allow a divine foot in the door. So therefore, you now start to see the link between atheism and Darwin's theory of evolution. Because if atheism is true, forget the science for now, then something like the Darwinian history of life has to be true as a matter of logic. Now we're going to move on to the second last section. Darwinian evolution is unique. Why is it unique? Because it's the only theory in the history of science which has morphed from a valid scientific theory into a fully fledged religion, a political system, and an ethical system. And I'm not the one saying this. This is according to mainstream evolutionary biologists and historians of science and philosophers of science. I have three characters up on the screen. All three of them give you a different insight about how Darwin's theory of evolution went out of the realm of science and into the realm of being a fully fledged religion. On the left, we have Julian Huxley, an evolutionary biologist and atheist, and he published a book called Religion Without Revelation, which was Darwinism. And he was the first president of United Nations UNESCO. Richard Dawkins, in his 1980s book, The Blind Watchmaker, he again makes a very telling admission. He says, before Darwin, it may have been logically tenable to be an atheist, but after Darwin, we became intellectually satisfied atheists. And even in his book, The God Delusion, which is the most famous polemic against religion, the central argument of the main chapter of the book and the central point, there's 6 points that he puts together, it's got to do with Darwinism. That's the driving force. And at the bottom there, we have Michael Roos, who recently published a book with Oxford University called, and the book's title just gives it away, Darwinism as Religion. And in this book, he does believe in Darwinism. He is an atheist. He is a naturalist. He says, Darwinism from the beginning till now is a fully fledged alternative to mainstream religions like Christianity. Secondly, Darwinism as an ethical system. And now this is the part of Darwinian evolution which is generally overlooked. Now imagine if I said to you guys, do you know what? I believe in general relativity. Oh no, forget that. I believe in gravity. Gravity works, right? But I said, gravity works every single place in the entire universe, except for the UK. And in the UK, there's only one part where it doesn't work, which is this university, and in this room, gravity doesn't work. Other than that, it works in every single part of the world. You're going to say, you're bonkers. What are you talking about? How can you make an exception? Well, if Darwin's theory of evolution is true, then something like this has to be true as a matter of logic. Now here we have 12 stages of human evolution. We have, at the bottom, we have 6 types of great apes, and at the top we have 6 types of human beings. Now the difference between step 7 and step 6. Step 6 is the African man, which we have some brothers at the back there. And we have actually, we almost have every type of human being in this room, roughly, right? 1 to 6. Now, as you keep going down, you get to number 1, which is the Caucasian. The distance between the Caucasian and the African is 5 steps. And the distance between the African and the ape is 1 step. Now, I'm sure somebody may mutter in the room, that's inherently racist. Well, this is an idea which was accepted at the time, and it was even accepted by Darwin himself. And here's the proof. This picture is in a book published by Ernst Haeckel, who was a contemporary of Darwin, who him and Darwin used to communicate with each other, who was the main proponent of Darwinism in Germany. In fact, Ernst Haeckel published his book on human evolution, and Darwin published his own book on human evolution, The Descent of Man. And Darwin said, if I knew, this is his review of Ernst Haeckel's book, If I knew that Ernst Haeckel was going to make this book, I wouldn't have made The Descent of Man. And he not only acknowledged this type of very racist idea, he himself in The Descent of Man, which anybody here can just go Amazon, download it, he describes African people as having ape feet. He describes that in the future, the civilized races, which is the Caucasian, will wipe out the savage races, which is steps 2 to 6, and I'm probably at step 4 because of the beard. So, we're in trouble. I mean, we're all in trouble. You might survive if you're maybe number 2, slightly Chinese looking, like your Malaysian brother here. But anybody other than that, you're going to get taken out. Now, in The Descent of Man, clear racist ideas. And it's actually unavoidable. If Darwin's theory of evolution is true, and then you apply it to human beings, there has to be a hierarchy of human beings, right? There's no way you can escape that. Now, Leonard Darwin, who was Charles Darwin's son, he was the father of eugenics in this country, and he said something very interesting. He said, one of the hardest things we're going to have to deal with in the future is what to do with the savage races, which is step 2 to step 6. Now, in the beginning of the 20th century, we had Otabanga, who was an African man who was discovered in Congo by European explorers. His family was killed, the poor guy. He was chucked into a zoo in New York, a human zoo, and he was paraded as a missing specimen between step 6, which is the African man, and step 7, which is a full ape. So they believed him to be between stage 6 and stage 7. Now, sadly, Otabanga, he ended up committing suicide, and he was just one of many live missing links which were paraded around the world. Now, post World War II, all this stuff is whitewashed. No one wants to talk about it anymore. In fact, I was reading in the Philosophy of Human Evolution, published by Cambridge University, which I expected to cover this topic. They did a great job, a great cop-out. I mean, they didn't want to go near this. The only sort of thing that Michael Roos was writing, well, we're all African anyway. Well, of course we're all African in this picture, because the evolution starts at stage 12, which is in East Africa, and then it goes up to stage 1. No one denies, that this is saying that we're all African. The question is, does the hierarchy exist according to Darwinism? Well, it clearly does. But like I mentioned, this is something that Darwinists don't actually want to talk about, what happened in the past, and what they have to accept is true, which is human beings have to have some sort of hierarchical system. Also, Darwinism has become into a political system. You have books like A Darwinian Left, Political Gene. Also, Joseph Stalin, he admitted that he became an atheist. What drove him to atheism was reading The Origin of Species. And he was responsible for huge political slaughter. I mean, millions died in Russia. And he himself said, I was applying natural selection to to social class, right? And even in the writings of Darwin, when he spoke about the Ottoman Turks, which was the Muslim empire at the time, when they fought the Europeans and the Europeans beat them in a battle, Charles Darwin said, the savage races have been beaten, the savage Turks have been beaten hollow by the civilized Europeans. Why? Because, they're savages, and savages are, beaten by those who are superior, which is the white man. And he made the prediction, which is very clear in The Descent of Man, that the civilized races are going to prevail all over the world. And in fact, he was justifying what had been happening in 3 continents. Australia, the savages were being wiped out. North America, the savages were being wiped out. And South America, the savages were being wiped out. And in Africa, the savages were being wiped out. And you'll find that within The Descent of Man, this sort of political commentary. Okay, lastly, I want to cover Islam, evolution, and Darwinism, something which I did cover previously. Now, what's very, very important for us as Muslims to do is not to accept the Christian narrative about the history of life on earth and then try and just do what they do. So, Christians usually have, they usually promote this thing known as intelligent design, and they also say that, look, all of the species on earth, all of the different kinds, these different kinds, they don't actually change. Now, it's very important for us as Muslims. Allah says in the Quran, do not speak about that which you don't know. So, in terms of human beings and human lineage, we as Muslims, we can confidently say that human beings and chimpanzees, theologically, we do not believe them to have a common ancestor, human beings and apes. But in terms of other biological life, there's silence in the Quran. Did the whale evolve from a land-like mammal? Possibly. We don't know. We can't say it definitely didn't, which is what biblical literalists do. They say, no, it definitely didn't. So we as Muslims, what should we do, especially those of us who work within evolutionary biology? Well, I'll give you a practical piece of advice, which is a practical piece of advice which my friend actually applies. My friend, Dr. Fareed Khan, you can find his video on the iERA channel as well. He's an evolutionary biologist. Alhamdulillah, he has a PhD from Cambridge. He works within this field and he works to try and save lives. And the driving force in his life, working within evolutionary biology, is the Quranic verse, whoever saves the life of one saves the lives of all, right? Because that's really what evolution is about. When you look at all the literature, this technical literature, forget all the popular stuff, they're not talking about human chimpanzee history in the tree of life. They're just concerned about saving lives, trying to come up with new antibiotics. Penicillin is, dying off and all the rest of this sort of stuff. Now, what can we as Muslims do? We can accept Darwinian evolution as a working model, as a working theory, as a working paradigm. But it doesn't mean that we accept it to be absolutely true, because even secular academics agree it's based on a probabilistic framework which has assumptions, and there are disputes about its most fundamental ideas. So we can accept it as a prevailing idea, but we don't have to accept it to be absolutely true. And even David Stove, who's a philosopher of science, he's an atheist, in his book Darwinian Fairy Tales, and he calls Darwinian evolution a slander on human beings, right? It's not just all about survival and reproduction. He says, look, even though it's the best thing we have in biology, it's the prevailing idea, prevailing theory, and he accepts it as that, he says it's not absolutely true. So we as Muslims would do the same thing. So in this lecture, I have covered very, very importantly, the most important section is the section at the beginning, because I spoke about the scatter graph problem and the black swan problem. And then I spoke about why Darwinian evolution is based on a probabilistic framework with assumptions and disputes. But I didn't need to do that. If you understand the black swan problem and the scatter graph problem, you automatically know that Darwinian evolution or steady state theory or string theory or any theory in science cannot be absolutely true. And I explained why it's based on a probabilistic framework with assumptions and disputes. And lastly, what I want to end upon is this. Just a few decades ago, there was a conflict between our theology as Muslims and physics. Physicists believed in the steady state theory. They believed that the universe had no beginning. And in the Quran, it's clear the universe had a beginning. Now, the steady state theory has gone through a paradigm shift, and we have the Big Bang theory now with 17 different models. And it's more in line with the Quran. But what would we as Muslims have done 50, 70, 80 years ago when the steady state theory was accepted by everyone, including people like Einstein? Would we just go around trying to argue with every single physicist that it's wrong? No. We would say, well, this is a prevailing idea in physics and we accept it as Muslims and we accept it as a working model, working theory, working paradigm, but we don't believe it to be absolutely true. Maybe something will come in the future which will challenge it, which is actually what happened. Sadly, what does happen within this field is Muslims follow Christians and they just start, trying to challenge everybody who believes in it. That's not the right way to actually do it. The correct thing Islamically, and the correct thing, even if you're not Muslim, is to understand science only gives you working models which can then change. And we need to understand we have a duty to be involved in science more than, I would say, other religious faiths or even people who are non-religious. Why? Because science as a method came from the Muslim world. The first scientist in history, according to even mainstream secular academics, historians like David C. Lindbergh, the first scientist in history and the first person who came up with the scientific method which we're using till today to make all of our technology is Hassan ibn Haytham, who lived approximately 1,000 years ago, hundreds of years before Francis Bacon or Galileo or any of these characters. And he was not only a scientist, he was also a Quranic scholar. And he was the first person who actually, and one of the things that he said was, in his biography, what drove him to do science was to become closer to Allah, become closer to God. That was actually his objective. And sadly nowadays, science is associated with atheism. But as we know, the more you discover about something, the more you discover about the human body, the more you discover about the universe, if anything, it should lead you towards God, not away from God. Science explains how, God explains for us why anything exists in the first place. So discovering how doesn't challenge why. Everything good I have said is from Allah, the Creator. Every mistake is from myself. Jazakallah khair for listening, and I look forward to your questions.